Good afternoon, everyone. This is the Game Sage here. Welcome you back to my second GameMaker Studio tutorial. And in my previous video, I basically introduced everyone to the world of GameMaker Studio. And I just went over every single one of these folders and what they are and how they come together to make a video game. Didn't go into too much detail in anything at all. Again, it was just more of an overview. I did go a little bit into sprites, objects, and rooms, but for the most part, again, it was just an overview video explaining the GameMaker Studio environment and how all these folders work together to create a video game, and a brief description of what all of these are. So what did we do last video? Let's go ahead and run the game just so I can show you. Wait till it compiles, and there you have it. So as you can see, we added our player character into the game, and we added them into a room, which right now, if we hit left, up, right, or down, nothing happens, and that's all we really did. So very brief, very basic. We really didn't get into anything in detail at all. So, quickly, we created a sprite, just briefly, a brief overview of what we did. We created a sprite, we named it SPR player, and I'm going to get into naming conventions in a second. So we created a player. We loaded the image, and I had a link standing image, I think it's PNG format. I don't even know what the hell format it's in, but we had a link standing picture, and we imported him, removed the background, all that, created a sprite for him. So that was it for that. And then we created an object player. Now the difference between an object player and sprite player, and this is why naming conventions are important, and why I'm going to get into it, or I'll talk about that. An object player is basically the controller for the sprite. So the sprite represents our player's image when we add it to the game. Everything and anything visual in your game is a sprite. But you have to have some sort of a way to manipulate these sprites. You have to have some sort of a way to make collisions happen, or you know, things. Every event, and when you play a video game, everything and anything that happens is controlled, and that's called an object, which is what this is. What objects do is it controls and manipulates your sprites and all this other stuff to make things happen. So we created an object player, and we set it to SPR player, the sprite of it. So all that means is basically the object is the physical thing in your game, and we create an object and we set its properties, its visual property, to the sprite player. I hope that makes sense. If not, you know, feel free to ask questions in the comments. But basically, there's the sprite image, and then there's an object that controls that's going to end up controlling everything our player character does. Okay, hit OK. And then the last thing I did was I created a room. And basically a room is just our level, our game level. There's no design or anything going on. It's just a blank screen right now with the background color, this greenish color. And all I did was I put the character into the game, and I scaled them up because I made it a 1280 by 720 window or resolution. I named the room test, or RM test. And I added him into the game, scaled him up a little bit so we can see him, check, and then that's it. Those three things created a game for us. I didn't do anything complicated at all. So, let's get to movement. Now, before I do anything else, I want to talk about naming conventions. So you might have noticed in my previous tutorial, as well as this one, that I've really been emphasizing this naming convention thing. And to be honest, it's probably not as big of a deal as I'm making it out to be, but it is quite important, and here's why. Let's say you have a game that you're 75% done with it, and you have thousands and thousands of resources in your game, like hundreds of objects, hundreds of sprites, hundreds of sounds, just all kinds of things. And then something happens and you're forced to take a break from creating the game for like a month or two. Okay, and then a month or two passes, and you come back and you want to get back into game development, go back into creating your game. You're going to be confused as all hell, because if you don't name, let's say you don't use proper naming conventions, and for example, this SPR player, you just call them Link. Let's just say you call them Link or player. Here, we'll just do player for Nate to make things simplistic. You call them player, okay? Then you have an object, and you can't name them player because you already have a resource called player. So if I hit OK, it's going to say a resource with that name already exists. So you can't call them the same thing. So you're like, okay, I'll just call them the player or something like that, okay? I mean, right now it makes sense because you have a Sprite. Okay, this is a Sprite player, and then this is the player. Like, you control the player. It might be something that makes sense at this given time, but 3 months later, you might look at this and be like, what the hell was I doing? I don't remember. Now, if you use proper naming conventions like SPR player, or another way a lot of people like to name their resources would be SPR player, like that. That's another typical naming convention. I just stick with the underscores. It's what I'm used to. So I'll just do SPR player and object OBJ, standing for object player. If you do something like that, you come back to your code or your game in 2 months, and you'll be like, okay, I remember. It'll come to you quicker if you use smart naming conventions. So I've put together a quick little file using PaintShop Pro, and this shows you the typical and common naming conventions for GameMaker Studio. As you can see, Sprite is the naming convention I've been using, SPR underscore. Sounds, I typically do SE underscore or BGM underscore. SE stands for sound effect, and BGM stands for background music. It's just something I've always remembered it too. Other people for sounds also use SFX, I believe, underscore. And again, you don't have to use the underscore thing. It's just the way I do it, and I think it looks cleaner that way. Backgrounds, I've always used BG underscore. Paths, this one you can... It's really up to you. I always do PTH underscore. I've seen just someone write the whole word path out underscore. Scripts. This one's interesting because I like to use a naming convention for scripts. Or, let me rephrase that. I typically do not like to use naming convention for scripts because it makes it a little confusing once you understand what a script is later on. But a lot of people do use like script underscore and then the name of the script. Don't worry about this one. This one's a little confusing, but you can use a naming convention for this one, or you don't have to, so don't worry about it. Shaders, I always use shader underscore, but there's a lot of people use SHD underscore. It doesn't really matter. Fonts, FNT underscore. Timelines, this is another interesting one. A lot of people use TML underscore, like timeline. I use SEQ, which stands for sequence, because that's really what a timeline is. It's just a sequence of events in your game. So for me, when I use sequence, it'd be like, for example, let me think of it. Sequence boss fight, or sequence boss movement, something like that. I understand it better that way. You can name it whatever you want. Object, OBJ underscore, rooms, RM underscore. You don't have to go by this naming convention. You can do whatever you want. And really the truth is, as long as you find a comfortable naming system that you can understand when you go back to your code, 4 months from now, that's fine. Whatever works for you. So anyways, I've wasted a lot of time on that. But it is kind of important to just bring that out, just to keep your code clean. Because if you use smart naming conventions early on, then you're gonna be happy about it later. When you're not gonna be complaining when your game is a cluttered. You'll be complaining when your game is a cluttered mess. Whereas if you follow this now, it'll be neat and you'll be able to follow it. So enough about that. Let's finally get to the actual tutorial. And again, let me run the game one more time just to show you. So right now we have just a character Link drawn to the screen and can't move. Right doesn't do anything. Left on the keyboard doesn't do anything. Down and up does not do anything. So we're going to add player movement. We're going to make it so that when you press left, he's going to move left on the screen. Right, he's going to move right. Up, he's going to move up. And down, he's going to move down. So let's get into how to do that. Okay, so the first thing we want to do is open up our object player. And as I've mentioned in my previous tutorial, pretty much everything that we're going to want to do that involves controlling our character, our main character, you know, such as jumping, walking, fighting, just anything involved in our main character, we're going to want to do in the object player. So in my last tutorial, I briefly touched on objects, but I didn't really get into it much, so let's get into it. Objects are comprised of two main things, events and actions. Events I also refer to as triggers. What this means is whenever something is triggered, perform actions for that trigger. So if I click on Add Event, you'll notice that they give us all of our possible triggers already. So for example, create. What this means if I put Add Event and then I click Create is whenever this object is created, so the trigger is the object was created, okay? Perform whatever actions we put into this box using all of these commands given to us. So whenever the object is created, perform whatever actions we put in here. We have other triggers such as destroy. Whenever this object, which object player, is destroyed, perform whatever actions we put in here. Then there's other stuff like alarms, steps, collisions, keyboards, etc. Step is very important. We're going to be getting to that a little bit later. But what we're looking for is, well, let me delete these events, these two things here. Well, what are we looking for? What's our objective of this tutorial? We want it where when we're pressing the left arrow key on our keyboard, we want to move left. When we're pressing the right arrow key on our keyboard, move right, up, down, you know, using up and down. So that's what we want as our trigger. Do we have that available? Let's see. Add event, sure we do. Keyboard, left. So that's the trigger is whenever we're pressing the left arrow key. Let's add the other four. Left, right, up, and keyboard down. So whenever we're pressing the left button on our keyboard, perform whatever actions we put in here, up, right, and down. Right now we have no actions. So what is it we want to do? Well, whenever we're holding left on our arrow key, we want to move our object player or sprite to the left. Well, here we have a bunch of predetermined crappy drag and drop options available to us. Sure enough, the very first one on the tab is the move option, move fixed. So all we have to do is just drag the move fixed into the actions command for each one of these triggers and just move it in the corresponding direction. So for example, whenever the left arrow key is being pressed, it's going to start moving in a direction, which is it's just this move fixed drag and drop I put in there. We're going to be moving left, and let's just do a speed of 3 for now. So we're going to be moving left 3 pixels every frame. We can do the same now for the other 3 directions. So up, whenever we're holding down the up arrow key, let's drag and drop the move fixed into the actions. Direction up, 3 pixels. Right, same thing. Right, 3 pixels. And down, down 3 pixels. So what this means is whenever we're holding the left arrow key, we're going to be moving left 3 pixels every frame. Up 3 pixels every frame, right, and down. And remember that our game runs at 30 frames a second. So what this means is every second we're going to be moving 90 pixels in whatever direction. So now if I go and run the game, it should technically work. Let's see. So if I hold the left arrow key, he's moving left 3 pixels. If I hold right, he's moving right. If I move up, he moves up. If I move down, he moves down. However, there is one big problem. And it's this. If I press left and I let go. I pressed up and I let go. I press down, I just let go of the keyboard. I press right and I let go of the keyboard. He does not stop moving. Luckily, this is an easy fix. If I go back to the object player and I go back to add event, keyboard, there is an option here called no key, which means when no key is being pressed, do something. What I'm going to do is I'm going to go back to the move fix, drag it into the actions, and there is a square in the middle, which means don't move or don't move in any direction. And we'll put speed of 0, which means whenever no key is being pressed, he's going to stop, or he's going to move in no direction with a speed of 0. So that should fix our problem. Let's run and test it. Sure enough, I can move up, left, down, and right, and as soon as I let go of any of the keys, he stops moving completely. Now, this is great and all, but this is not a great way to program. First of all, yes, I can move in all 4 directions, but it's a little, like, iffy. Like, it doesn't feel smooth the way I'm moving. I don't know how to explain it. It doesn't work because while this is a great system for beginners, you know, to learn Game Maker and all, this is not very efficient. Like, when your game becomes very complicated and you have a million things going on, and if your player gets stuck in a wall or something weird happens, it's going to be a pain in the ass to deal with all this drag and drop stuff when everything is in separate windows and commands, and it becomes an overall nightmare. Which is why Game Maker Studio, everyone recommends you learn how to program and you learn how to use GML, the Game Maker language, which is what I'm gonna teach you now. Very basic thing here. So first thing I want to do is let's get rid of this no key. We don't need that anymore. When no key is being pressed, who cares? That's stupid anyways. So don't worry about that. And let's just get rid of all these actions, these move actions we have. Delete, delete, delete. So we're going to keep all the triggers, which means when the left arrow's key is being pressed, when the up, right, and down, we're going to keep all 4 of these triggers. The only difference is for each one of these triggers, instead of doing the move action, where we're moving fixed, I'm going to code it in. I'm going to code our movement in, or this object player's movement in. To do that, the 4th tab is called Control. And if you go to this section here where it says Code, the very first tab is Execute Code. The first thing you can drag and drop is called Execute Code. So let's drag that into our actions. And when you do, you're going to get this new window that pops up that allows you to use GML, the Game Maker language, to write any code you want, really. So what is it we want to do? Obviously, we want to move our character in all 4 directions. Well, in school, most of you probably learned of X and Y in your coordinate system, which means X represents your character's X position, where he's moving left and right, and Y represents his Y position, or Y axis, when he's moving up and down. The same works in programming and video games and computers. There's always an X coordinate and Y coordinate. And whenever you create an object in Game Maker Studio, every object has a position on the screen. It comes with an X and Y coordinate. Every object by default is going to have an X position, or X coordinate, and a Y position, or in this case, X variable and Y variable. So we can manipulate the X and Y to move our character around the screen. So when the player is holding down the left arrow key, what do we want to do? We want to move our character, our object player, to the left. How do we do that in Game Maker language? Simple. X is equal to X minus 3. Remember how we were moving originally when we did the move, the drag and drop move? We were clicking the left thing, the left direction, and then just setting it to 3. This is essentially the same thing, except better because we're pure hard coding it. So every time the left arrow key is pressed, move the X position 3 pixels to the left, which is what this piece of code is doing. The semicolon is just the way coding works. If you guys don't know a lot about programming, I definitely recommend at least picking up a really basic programming book. Learn about variables, if statements, conditions, and functions. The basics. You can learn this all in like a day or two, not even. So every time we're holding the left arrow key, we're moving the object player's X position 3 pixels to the left. So for example, let's say his current X position was 60. Okay, the next frame of the game, it would be 57. Next frame of the game, it would be 54. And then 51. Every time it runs this line of code, it would subtract 3 from his X position and actually move him on the screen. So X equals X minus 3. And that's all we have to do for left. And then we want to do the same thing for the other 3 directions. So right, let's do right first. And there's a reason why I'm doing right next. So again, click on right, actions, 4th tab, controls, code, execute a piece of code. This is just going to be the inverse of the other one. X is equal to X plus 4. Okay. And now we just have to handle up and down. And this is where a lot of people might get stumped, and this can confuse a lot of people. So let's start with up. I'm going to do something here, and you're going to be confused, but then I'll explain it. So up. We're going to do the same thing. We're going to drag the execute code into the actions. But this time I'm going to do y is equal to y. Now you would think plus 4, right? Wrong. Minus 4. And I'm going to explain that in a second. And down I'm going to do y is equal to y plus 4 for down. So now we have up is y equals y minus 4, and down is y equals y plus 4. And at this point, you're probably like flipping a lid, and you're like, what the hell is going on here? Well, I put together a little graph or a little picture here to best describe what's going on. So, back in school, most of you guys probably learned about the regular coordinate system and graphing. And you know that typically, let me use a different color because red kind of sucks. Let me use just like, let's use a green. So darker green. So you learned back in school where, let's just say if something was drawn like over here, and let's say this was at position 4, 4. So you learned back in school that this image, or whatever you draw here, would be at coordinates 4, 4, right? Or if you drew something down here, you know that the coordinates, so this represents the x and y. You guys know that. And this is y and x. So, if something was drawn here, you know that the x position would be 0 because it's not moving on the x. And then y would be, let's just say this is 4 as well. Y would be 4, so this would be 0, 4. This is what we learned in school. However, when it comes to normal graphs, the origin moves in the positive direction. When it comes to computer language, or computers in general, origin moves in the negative. And this is what confuses a lot of people. So ignore the way you guys learned it in school, because this is wrong when it comes to computers. So let's look at this window here, because this is the best way I can explain what's happening. Imagine this is your game screen, okay? This is where our character was drawn. So let's say this is... This is the Link character, okay? Which is kind of accurate. This is where he was sort of in the middle of the screen. Well, in our screen, the very top left of our screen is considered position 0, 0. Because this is the first pixel that's drawn out on the screen. And the very bottom right of the screen is pixel 1280 by 720, because if you remember, I made the game window 1280 by 720. So our character's kind of by default, or where we place them, he's kind of drawn in the middle of the screen, so it's probably like 640 by 480 or something like that, whatever the center is. So let's think about this for a second. If we're thinking about it from the point of view of a computer screen, when you move left, you're still moving in the negative direction. If you move right, you're moving in the positive direction. We know that because the x here is 0. Okay, the x-coordinate is 0. And the max x-coordinate, you could go from 0 all the way to 1280. We know that because that's the size of your screen. So if you're moving left, you're moving closer to 0. If you're moving right, you're moving closer to 1280. Makes sense, right? Well, now think about up and down. Okay, when you're moving up and down in the game screen, well, if you're moving up, you're moving closer to 0. If you're moving down, you're moving closer to 720. So, naturally, if you're here, let's say that the character is here, well, his Y position is going to be like 40 or something. If he's down here, his Y position is going to be like 720. So think about that, if he's closer down here. So, if he's over here, it would be like, 680. So as you can see, if he's here, it would be, I don't know, 500. I know it's not the scale, but think about it. As he's moving upwards, he's getting closer to 0. As he's moving downwards, he's getting closer to 720, which is our max Y. So if you think about it from that point of view, it makes more sense of what is going on in the code. Because in the code, left is moving in the negative direction, so that's right. So actually, you know what? The best way to describe this, if I go to the room, here we go. Here we go. This is perfect. Right now, he's at, look down here. This is our X and Y coordinates, okay? So look, pay attention where my character is. Right here, he is moving left. See that? See how the X is moving left? If it moves right, the X is moving right. Now, watch the Y. The Y coordinate is currently 352. If I move up, it's going in the negative direction. If I move down, it's going in the positive direction. So, I hope that makes sense. Let me close this out. Code-wise, so just to summarize, whenever the left arrow key is being pressed, we're executing this piece of code, which happens to be, which I can't open it for whatever reason. Why? This is why. X equals X minus 3. Okay. Whenever right is being pressed, X equals X plus 4. And I don't know why I did 4. I just realized it. It should be 3 because I'm not being consistent. So left is X equals X minus 3. Right is X equals X plus 4. Up is 3 and 3. I don't know why I did 4. I must have not been paying attention. So every time the left arrow key is being pressed, the character, the object player is moving in the negative, the X in the negative direction. So X minus 3. Up is going to be Y minus 3. Right is going to be X plus 3. And down is going to be Y plus 3. I hope that makes sense. I know it can be a little confusing to wrap your head around that, but that's probably the best way I can explain it. And that's really about it. So now if we run our game, let's test it. Whenever we press the left arrow key, he moves left, right, right, up, up, down, down. And here's something else cool. If I press left and up at the same time, look, I can even move diagonally. Isn't that great? So already, the default movement system, or drag and drop, sucks because, look, I can press everything at once. So I can actually move diagonally using my own code. Isn't that great? So, That's about it. I mean, it works. As soon as I let go of the button, he stops moving. I don't even have to have a no movement trigger or anything stupid like that. So that is the power of coding. But there's actually a way to do this that's even more efficient than when I am doing it. But I'm not going to go into that this episode. In my next tutorial, I'm gonna cover it. So my next tutorial is gonna be, I'm gonna condense all of this into one execute code. So all of this, left, up, right, and down, is gonna be all in one action, basically. So I'm going to do that, and then we're going to get into collisions. So I'm going to do basic collisions and also gravity. So that's all of the time I have for this tutorial. I hope this was helpful. If you guys have any questions or don't understand anything I did, please ask down below. Otherwise, I hope you guys all have a great weekend. And yeah, that's about it. So this has been the Game Sage. I will see you guys later. Peace out, and have a nice day.